Hey guys, Mr. Riz here. So we are going to review for our Chapter P calculus test. So I have this review quiz made here. This one will be graded, so it probably wouldn't be a bad idea to watch this video and take it along with us, or maybe take it beforehand, see how well you do, and then watch this video to go over the problems. So I'm going to go ahead and get this started, and I'm going to preview this. You guys will just take it. And we're going to move along here. So let's see how well this works. Okay, so first couple questions. These are actually really easy to do on Desmos, but we'll try to go ahead and do them without Desmos. So let me bring up my annotation tools here and let's start drawing. So if I want to find the y-intercept, I'm going to make x equals 0, solve for y. So y would equal 0 squared minus 8 times 0 plus 12. That means the y would equal 12. So the y-intercept is at the point 0, 12. The x-intercept, we need to go ahead, set the equation equal to 0, and solve for x. Now solving for x is usually a little bit of different work. In this case, we have a quadratic, so let's see if we can factor it. What two numbers multiply together to get us 12, add together to get negative 8. That'd be negative 6 and 2. And if we solve both of those, that means x would equal positive 6 and x would equal positive 2. If we're going to name the points from left to right, it would be at the point 2, 0 and the point 6, 0. If we would have graphed this, we would have just had a parabola. It would have been pretty easy to figure that out. Okay, let's clear this off. Let's do the next one. We got a lot of problems here, guys, so if you ever think I'm going too fast, just pause the video and go back and watch that step by step. Alrighty, next problem here. Okay, we have to set 0 in for all the x's. So y equals 0 minus 3 times the square root of 0 plus 4. So that would be negative 3 here times the square root of 4 is 2. So this would actually be y equals negative 6. The x-intercepts, what we're going to do is set y equal to 0, set the equation, or solve for that equation. Well, this is technically factored here. All right, so x minus 3, what would make that equal to 0? What makes this part equal to 0? That would be a 3. So x equals positive 3 is one of our roots. And the other thing is, okay, when does the square root of x plus 4 equal 0? Really, we just care about the inside. When does x plus 4 equal 0? X equals negative 4. So if we're going to name these points from left to right, it'd be from negative 4 to 3. You know what I should do? I should plug in these answers to see if I am getting them right. All right, so what was this one again? This was at 12, and this one was at 2 and 6, I believe. Yeah. And then this was negative 6, and this is 3 and negative 4 and 3. You got to put in the right order, negative 4 and 3. And all I'm doing, I'm just going to double check that my answer key set up for when you guys take this. Ooh, okay, so there's a problem I do need to change. So let me go ahead and pause this video and I'll fix this here. Okay, here we go. Next, we're checking for symmetry. We're going to check for symmetry. First, the x-axis symmetry, how we do that is we go through and we make the y negative, and we see if we get the same equation. Well, if the y was negative, to make this back to a positive y, I'd have to change the signs on everything else. So it would be a negative x to the fourth and a positive x squared and a negative 3. Okay, so it is not x-axis symmetry. Y-axis symmetry, I'm going to make all the x negative, so a negative x to the fourth and a minus negative x squared and a plus 3 because there's no x there. And if I do simplify that, if I have a negative x to the fourth, that just becomes a positive x to the fourth. And this would become a, this would become a positive and then negative. So a negative x squared and then plus 3. So this is actually the same thing that we started with. So it is y-axis symmetry. We should double check for origin symmetry. It's when we make the y negative and the x negative. And you guys can probably figure this out before I get done writing it out. That this is just going to stay the original equation on the right side. And then when we have the negative here, it's going to switch it back over like this problem. So it is not. This problem is just y-axis symmetry. All right, moving on to question 4. Okay, go through all those symmetry steps again. So good review here if you just watch this. Okay, x-axis, I'm going to make the y negative. So I get negative xy equals negative 2. So positive xy would equal positive 2. So that is not x-axis. I could do the same thing on the y-axis, make the x negative, but we'd get the exact same thing. Negative xy equals negative 2, xy would equal positive 2. So it's not y-axis origin. I'll make them both negative. Now, if I have a negative x times a negative y, that turns into a positive xy, and we do have the same equation we started with. So that is symmetry through the origin. All right. Question 5 here. Test for symmetry with respect to each axis. Oh, so just more symmetry here. All right, so the one thing I look out for symmetry are like square terms. So if I make this x, or make the y negative, and I square it, it would stay positive. Nothing else would change, so it's going to be good. Y-axis will not work here, because if I make this x negative, that would become a +9. There's no way to undo that. And same thing with origin. The y would stay the same, but the x would be the opposite. Okay, this one here. If I make the y negative, it would change this sign over here when I turn it back to positive, so x wouldn't work. Y-axis, if I make this negative, negative x minus 4. Well, if it was just a negative x inside of the absolute value, it'd be okay, but since we're shifting it to the left 4, it doesn't work out. Like, so just think of an example, like is 1 minus 4 the absolute value? Is that the same thing as negative 1 minus 4? No, it's not. So it's not y-axis. It wouldn't be origin because neither one would cancel out. So there would be no symmetry in this one. And you guys can always double check these by graphing. Okay, next we have solving systems of equations. Okay, you guys can graph these out. We can do substitution. This one's actually perfectly set up for elimination. So if we look here, x's are on x's, y's are on y's, numbers. We don't have to multiply anything here. So I'm going to add these rows together.
Thank you, teachers and students. At this point, our drill
divide by 2.
Make sure, staff, that you just retouch briefly with your periods 2 through 9. The students are in different areas of the building, of how they leave the building and how they would barricade the rooms they're in. We are on activity bell schedule, and we are pretty much in the beginning of first period, so I'll turn the bells back on, and have a great day. Thank you.
Yep. Oh, excuse me. I don't think I need to take the time to edit that out. Bless you. Thank you. Okay, so we figure out x was 2 by solving that out. We go ahead, plug that back in. We get 4 equals 4 plus y. We'll subtract. It's 5 and divide. 5 over 4. All right, and so we will type that in. I believe I have it set up where I can type in 2 here, and then I can type in 1.25 or 5 over 4. I'll double check that here. All right, next one we have a little bit more complicated here. So name the points from left to right. And here we have x squareds on top of x's. So even though these are similar, or kind of, we can't just do the elimination with this. We will have to use substitution for this problem. So substitution, we want to get one of the variables by itself. I'm going to get this y by itself. So this y would equal 1 plus x, or I'm going to put x plus 1. If I just add that x over. Now what we're going to do is we're going to take that information, that y value, and I'm going to replace it in the top equation here. So I get x squared plus x plus 1 squared equals 1. Or x squared plus x plus 1 times x plus 1 equals 1. So we have to FOIL this. So x squared plus x squared plus x, and then in the inside is another x, and then plus a 1 equals 1. So we get 2x squared plus 2x plus 1 equals 1. All right, so we have a quadratic. We need to set this equal to 0 to solve. And so I get 2x squared plus 2x. If I minus the 1 over, that 1 goes away as well, equals 0. All right, after we set it equal to 0, we factor. So we can take away a 2x from both of these. And so I get an x plus 1 when I factor out a 2x. And we're going to set both of these equal to 0 and solve. All right, so when does x equal, or when does 2x equal 0? Well, that's when x equals 0. And when does x plus 1 equal 0? That's when x equals -1. So if we're going to name these points from left to right, we have -1 is our first x, 0 is our next one. Then what we need to do is plug in those numbers to find the value of y. Well, we know right here, y equals x plus 1. So y would equal, in this case, -1 plus 1, which would be at 0. And then this one here, y would equal 0 plus 1, which equal to 1. All right, so leave that on here so I can type these in. -1, 0, and then 0, 1. All right, next what we need to do is find the equation of the line that passes through the point and the given slope. All right, so these problems we're doing y equals mx plus b. We need to figure out m and b. Well, m is real easy. M is the slope. And so they tell us right there, to find the b, we're going to plug these numbers in. So we got y is -5, m is 7/4, x is 3. And solve for b. So we get -5 equals, okay, if I were to multiply this here, that'd be 21/4 plus b. And then I want to minus that over. Now I like to work with fractions because then I don't have to get a calculator out. I know -5 is really -20/4. And when I minus the 21/4 over, just figure out what b is, I can just combine those like terms. So -41/4 equals b. Now, if that was a decimal, I believe that's like -10.25. And I believe both of those answers are in there. So -41/4. Oh, and I forgot to type this one in. 7/4. All right, clear all my drawings. Okay, next, we can do the same thing here, but we're going to check something out. So one thing to watch out for here, we can't do y equals mx plus b for this problem. And so let's see, our m is 0, and our point y is 4, and our x is 5. We're going to solve for b. And so that means, okay, b would equal 4. So if we were writing this as equation equals y equals 0x plus 4, or just simply y equals 4. So that's the last choice there. Now, an easy way to remember this is if we have a slope of 0, that's a flat horizontal line, those are always y equals. And just look at the point. What does y equal? 4. This will actually help us out on our next problem. This next problem is undefined slope, which undefined slopes are straight up vertical. They're up and down. Up and downs always start out with x equals equations. And what does the x equal in this problem? -8. So that's how we can go through those ones pretty quick. I find the equation that passes through the 2 points. Okay, so this problem, we do need to find the slope and we do need to find the y-intercept. So let's find the slope by doing y2 minus y1 over x2 minus x1. So this would be -6 over 15, and that does reduce. Divide them both by 3, -2/5. Yeah. All right, so then we got to find our b by picking one of the points and using their x and y's. I'll use that one. It looks nice. So we get 5 equals m, -2/5, times x, -5, plus b. All right, so if I were to multiply this out, this turns out to be a +2, and subtract that 2 over, b would equal 3. So we'll type that in our answer here. We get -2/5 for x, -2/5 x plus 3. Yeah, okay. All right, next, evaluate the functions. Okay, the first couple problems are easy at this, then the next one's a little bit tricky. So if I'm going to plug f of 0, plug 0 in for here, 2 times 0 minus 6. Okay, that's -6. Plug in -2, 2 times -2 minus 6. Okay, that'd be -4 minus 6, that's -10. All right, now we have the fun part here, where we're going to split this up into 3 parts. First, we have f of x, which is 2x minus 6. And then the next part, we have minus f of -1. So I'm going to plug -1 into here. So a -1 would be 2 times -1, which is -2, minus 6, so that's -8. And then the whole equation is over x plus 1. So we'll make this whole thing over x plus 1. Now let's start working here to simplify this. This top would become a 2x. Let's see, this would be minus 6 and then plus 8. So that would be a 2x plus 2 over x plus 1. Well, if we look, we could factor out a 2 from the top. And we get that a 2 times x plus 1 over x plus 1, or 2 times x plus 1 divided by x plus 1. So those cancel out, and we just get left with 2. So moving and grooving here. Remember, if I'm going too fast, just, pause the video, go back. One thing that's nice about this all being digital. Oh, I guess we do need to change another one. So I'm going to pause this problem here, pause this video, and get back to this. Actually, I'm going to leave these blank. And I will adjust. I'm going to make a note because I'm already almost halfway through it, and I don't want to go back and retype in my problem. So question 14, I need to go back and fix. I thought I looked through all of them. Maybe I didn't check this one because it's not multiple choice. All right, what's the domain of this problem? Easiest way I would say to do this problem, guys, is go ahead, pull up Desmos. So I will allow you guys to use Desmos on the test, at least the part of the test that will be on Canvas. So we're just going to graph this expression out. That's the easiest way I find it. Now, we probably could figure out that this is a flipped square root going to the left. So if we look at this, the domain here starts at -6 and it's everything to the left of it. So it's any x that's less than +6. The range here is how low to how high. The lowest this graph goes is 0, and then this graph keeps going up and up and up. So it's any number of y which is greater than or equal to 0. Okay, next problem here, same thing. Let's type it in the calculator. 2 divided by x plus 1. We'll take a look at it on Desmos. You know what? I need to double check that you guys can see that. So on Desmos, we're looking here, the domain, it looks pretty good except for we do left. It does have a jump here going from left to right. And it jumps right at -1. So we can say that x going left to right cannot equal -1, which makes sense because the bottom, if we plug it in, would equal 0. Now the range going from low to high, low, and then there's a jump here at 0, and then high. Goes all the way up, so we can say y cannot equal 0. Okay, vertical line tests. You can go ahead, plug these in to determine whether they pass. So x squared minus y equals 0. We look here, vertical line, there's no parts where our vertical line would touch the graph more than once, so that passes. On the next equation, x equals 9 minus y squared. We'd look like right here at 0, 0, we'd have it touch a vertical line touches more than one spot. So this one would fail. An easy way to check for vertical line tests is if you have a y squared. It's a pretty much dead giveaway. Okay, so let's go back to this. I don't think we need Desmos for a little bit here. And make sure we are sharing this. Okay, here we go. Polynomial functions, whose graph approximates the given. So if I look at A, I want to know, what's the minimum degree of the polynomial function given the graph, and what's the leading coefficient? Okay, so if I look at this, we can find the minimum degree by counting the curves. This goes, our directions, it goes down, up, then down. So down, up, and down, so that's a degree 3. I know all odd degrees, if it was positive, would start up low, high, like that. So this is the flip of this. This must be a negative odd, or -3. Degree 3 with the leading coefficient that's negative. All right, so B here, let's count the curves. It goes down, then up, then down, then up. So that's degree 4. And any positive degree 4 would start up high, end high, and that one does. So that is a positive degree 4. Degree 4, that is positive. All right, C here, we go up and down. That's 2 directions, that's a quadratic. So that's a squared, a degree 2. And I know any square, if it was positive, would make a U shape, which this one doesn't. It's the flip of that. So this is degree 2 that has a negative leading coefficient. All righty, next, here we go. We go up, then down, then up, then down, then back up. So degree 5. And that one starts out the way it should be. It's degree 5, that's positive because it starts low and high. All odd powers start low and high. Okay. All right, inverse functions. Let's try to do both of these on the same. All right, so inverse functions, kind of, there was the 4 steps. What we need to do here is switch x and y around. So we would get, instead of y equals 3x minus 5, we're going to change this to x equals 3y minus 5. To get the y by itself, what we would go do is add 5 first, and then divide the whole thing by 3. So x plus 5 all over 3 would equal y, the inverse function, or that last choice. Next problem here, find the inverse function. So let's switch those around. So instead of being y equals 3 over x minus 4, we would have to switch this around to x equals 3 over y minus 4. And we'll get this y by itself. Fortunately, this is on the denominator, so the first thing we need to do is times x by that. So we're going to take this y minus 4 and times it by x. We'll distribute the x here. We get xy minus 4x equals 3. We're going to start to solve for this y. We'll add the 4x over, and then we'll divide by x to get the y by itself. So we get 3 plus 4x over x. And do we have that? Okay, so what's our choices lead us down to? Actually, we probably would have this choice here. Because if you think about it, what you can do with any fraction is to split it up. And we can make this 3 over x plus 4x over x, which is just 3 over x does not simplify, but 4x divided by x is a regular 4. Ooh, more inverse functions. Ooh, a fun one. All right, problem 21. I know we're moving, grooving. It's a long one here, guys, but it's a good review. A lot of stuff to cover. All right, what we got to do is switch all the x's to y's. Let's just do that now. So we got 4y plus 2x plus yx equals 7. So what we want to do is have everything on the y stay on this side. Anything that doesn't, we're going to move over to the other side. So we get 4y plus yx equals 7 minus 2x. We want to do this because the next step, let's factor out the y. Since there's multiple y's, we're going to factor out the y. So we get y times 4 plus x. And then we're just going to divide. So we get 7 minus 2x over 4 plus x. Let me see if we have that anywhere here. 7 minus 2x is right here. Oh, at the very bottom. And at the bottom we have 4 plus x. All right, here we go. Let's take out our unit circle here. Actually, I'm going to bring it over here and let's go through. I'm going to move my head down here at the bottom. So we're going to evaluate this. Make sure you can see. All right, sine. So what is the y value at pi over 2? The y is 1. Cosine of pi over 2. Cosine is the x. Up at that spot would be at 0. All right, cosine. What's the x at 5 pi over 4? 5 pi over 4 is here. It'd be a negative radical 2 over 2. Sine of 3 pi over 4. 3 pi over 4 is over here. Sine is the y. That's a positive radical 2 over 2. Tangent of pi. Here's pi. Tangent is the slope. What's the slope of this line here at pi? It would be 0. And what is the tangent of 11 pi over 6? 11 pi over 6 is here. It's a slope. It's going down, so it's negative. It's not 1. That would be this slope here. This would actually be less than that. It'd be negative radical 3 over 3. All right, keeping with this one here, give exact answers in the radians. We got the sine inverse of radical 2 over 2. So where on our graph is the y? Sine is the y, radical 2 over 2. Well, that would be at pi over 4. It's radical 2 over 2. And then also 3 pi over 4. Those are the only two locations where our y is radical 2 over 2. We're going to do cosine inverse of the same thing except for it's negative. So cosine, we're looking for x. We're going to see out one is that the x equal to negative radical 2 over 2. All right, so right here at 3 pi over 4, the x is equal to negative radical 2 over 2. And then also down here at 5 pi over 4. The x is equal to negative radical 2 over 2. All right, tangent pi, or tangent inverse of 0. So tangent, we're looking for the slope. So look on our graph here. When does our slope equal 0? Well, at 0, it's equal 0. At pi, it equals 0. And then the other thing to remember here, if we go all the way back around 2 pi, it would equal 0. Okay, now we're getting to the fun stuff towards the end here. All right, find the tan of the secant inverse of 13 over 5. Okay, so let's use a right triangle here. Help us out. Man, really good drawing these right triangles. All right, secant is the hypotenuse over the adjacent. So it'd be 13 over 5. Tangent is opposite over adjacent, so we do need to figure out this opposite side here. So 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. Subtract 25, that'd be 144. And hey, this works out nice. Oh, take the square root, that would be 12. So if we want to find the tangent here, the tangent, all we need to do is name the opposite, which is 12, over the adjacent, which is 5. So 12 over 5 would be the answer. Okay, another fun problem here. Evaluate the expression without using calculator. So, okay, let's set this up. Cosine is the adjacent over the hypotenuse from SOHCAHTOA. So that's 5 over 8. The cosecant is the flip of the sign. So this would be hypotenuse over opposite. So we do need to find this opposite again. So, okay, 5 squared plus b squared equals 8 squared. So 25 plus b squared equals 64. Let's subtract. B squared would equal to, if I subtract that, that would be 39. So b would equal, it doesn't come out nice, radical 39. So that'd be what, 3 and 13, that still doesn't come out nice. So the cosecant would be, the hypotenuse is 8 divided by the opposite, radical 39. Now that's not the right way to do that. We should write that by as multiplying by radical 39 over radical 39, which just comes out to be 8 radical 39 over positive 39. And that does not reduce. And there's our answer right there anyways. All right, a couple more fun ones. Here we go. I think there are 32 total problems that we're doing. Okay, what's the expression of the secant of the tan inverse of 7x? All right, so here we go. Tan is opposite over adjacent. So we'll make this over 1. The opposite is 7x. The adjacent is 1. Secant is the hypotenuse over the adjacent. So we do need to find this hypotenuse here. So let's set it up. So 1 squared plus 7x squared equals c squared. So 1 plus, now if we square this, it becomes 49x squared equals c squared. And so to get c, we just take the square root of that 1 plus 49x squared. Now, if we want to find the secant, we're going to take that opposite, or the hypotenuse value, and put it over the adjacent value, which is 1, which just comes out to be radical 1 plus 49x squared. Okay, we're getting to the nitty-gritty here. Next thing, same problem here, just more practice. So we're doing a lot of these practice here because this typically is the section people struggle with. All right, we have the sine of the cosine inverse of x to the 5th. Okay, so we got to set this up. Cosine is adjacent over hypotenuse. So we make this over 1. So the adjacent is x to the 5th, the hypotenuse is 1. Sine is opposite over hypotenuse. So we do have to find this opposite sine. So we got x to the 5th squared plus b squared equals 1 squared. So x to the 10th plus b squared equals 1. B squared would equal 1 minus x to the 10th. And so b would equal the square root of that. All right, now the sine is the opposite over the hypotenuse. Okay, that came out to be easy, 1. So it is just that problem there, the last one. All right, let's go ahead and go through this. All right, we might want to look at the unit circle for these next two problems. Let's see how well we can do. All right, solve the equation. So if I want to get rid of this tan to get the 4x by itself, I would have to take the tan inverse of the other side. All right, so next what we're going to do is look at the unit circle here. See if I can pop that up real quick. When does the tan inverse, when is the slope equal to 1? Well, that's pi over 4 and 5 pi over 4. Let's just double check pi over 4 first. Now, technically, if we were solving this, like, I don't want to stand. We were solving this for all the answers. We'd do both of those. We'd make one problem for pi over 4, and we'd make another problem for 5 pi over 4. But let's just solve this one to see, since it is multiple choice, we just want to know one of them. All right, so if I got pi over 4, I would need to divide this by 4. Dividing a fraction by 4 is the same thing as multiplying the denominator by 4. So this would be pi over 16, and that is a choice. The other choice this would be is 5 pi over 16, which isn't on here, but that would also be an acceptable answer. All right, 2 more problems to go. Here we go. Let's clear this out. All right, so same type of problem here. If I want to get rid of the cosine and leave the 2 minus x over 6 alone, I'm going to have to take the cosine inverse of -1/2. So look at our unit circle. When does the cosine equal -1/2? Cosine is our x value. When is it equal to -1/2? Well, that'd be 2 pi over 3 and 4 pi over 3. Let's just double check here if 2 pi over 3 comes out nice. Okay, well, we have 2 fractions here. We could actually cross multiply, divide if you want. The other thing we could do too is if you like cross multiplying, go ahead and do that. So you get like 12 pi over this. You'll just have to do more simplification here. I'm going to go ahead to get rid of the 6. I'm going to multiply this fraction by 6. So I get 2 minus x equals, okay, if I multiply 2/3 by 6, this just becomes 4 pi. And then, okay, let's subtract. So I get a -x is equal to 4x, or 4 pi minus 2. And then if I multiply by -1, I get a -4 pi plus 2. And what answer matches that? A -4 pi plus 2 would actually be the same as 2 minus 4 pi. And we didn't have to double check with the other one. Here we go. All right, here we go. Last problem. Solve the equation without using a calculator. All right, so if I want to get rid of this tan, I would have to take the tan inverse, I'd have to take the tan of the whole other side. Okay, so that would mean to get this simplified, I need to make a right triangle. So sine is the opposite over the hypotenuse. So we'll put this over 1. We have the opposite is radical 2x. Hypotenuse is 1. And tangent is the opposite over adjacent. So we do need to find this adjacent side here. So a squared plus radical 2x squared equals 1 squared. So we get a squared plus 2x equals 1. A squared would equal 1 minus 2x, and so a would equal the square root of 1 minus 2x. So the tangent is the opposite, radical 2x, over the adjacent, radical 1 minus 2x. Okay, so now math problem wise, if I needed to solve this, first thing I would do, I'd square all the terms. All right, I could square everything here to get rid of the radicals, and so I get x equals 2x over 1 minus 2x. Now the next thing, I'm going to put this over 1 because I think this would be easy to cross multiply. So if I cross multiply here, I'm going to have to distribute the x to the bottom, and I would get x minus 2x squared, and I'd set that equal to the other side, 1 times 2x, which would be 2x. And now I'm going to try to get the x by itself. Okay, so I'm going to move everything over to this side here just to keep the x squared positive. So if I move this 2x squared over to the other side, it becomes a positive 2x squared. And if I subtract this x over, I get a minus x. So then what we need to do, this is a quadratic, we will factor it. And I can factor out an x from both sides, and this becomes a 2x minus 1. And we're going to set those both equal to 0. So when does x equal 0? When that's x equals 0. And when does 2x minus 1 equal 0? And that's when x would equal a positive 1/2. So we do have two answers here of 0 and 1/2. All right, so let's see how I did this, see if I need to adjust my answer key at all. I'm hoping for an 8 out of 8. 7.88 out of 8. Ooh, let's see if I messed up. I wonder if it's question 14. Or maybe I did the problem wrong and I missed a common mistake. Which one did I mess up? Did I really mess up? The very last problem? Oh, geez, I know exactly what I did on the very, oh, I was so confident. You know what I did on the very last problem here? If I subtract the x over, this still stays a positive x. So this should have been a positive x, which means this would have been a plus 1, which means that would be a negative 1/2. So it should be 0 and a negative 1/2. There we go. Okay. So this review, even though it's long, hopefully you guys can watch this, help you guys out. There will be two parts to this test. The one part that you guys will take when you're at home will be the online part, and then you guys will take the in-person part when you guys are in class. So that would be on paper. All right, guys, thanks for watching this. Have a great day, and I think you guys will be ready for this big test. All right, see you next time.